Good morning, students. Welcome to physics class. Today we are going to discuss about charged particle, that is a cube, moving in a what here? Uniform magnetic field. When a charged particle is kept in a what here? The magnetic field, the how it is moves. Then what is its radius? What is its the time period? And what is the frequency? And also the angular frequency of this. We recover to find out all these things when a charged particle is kept in a what here? A magnetic field. Let us consider here is a uniform magnetic field. We have a uniform magnetic field. It is represented like this. Here is a uniform magnetic field. This uniform magnetic field, it is a perpendicular to the what here? Plane of paper. Just consider here is a paper. Okay. How this uniform magnetic field is a perpendicular line. So the entire thing is what here? Uniform magnetic field. I am applying like this. In this direction. This is the direction. This is the uniform magnetic field perpendicular to the what here? The plane of paper. When a charged particle is introduced in it, so what happened to the charged particle? It got a velocity and then it starts rotating it. With a velocity what? V. With a velocity, the V. So this velocity of a charged particle is once again the perpendicular to the water, the magnetic field, that is uniform magnetic field. So this is the plane of paper. Here the magnetic field is there, perpendicular to the plane of what here? The paper. When a charged particle is introduced like this, its velocity is in this manner. Okay, it's rotating in this manner. Then once again its velocity is perpendicular to the what here? Magnetic field. So therefore I can able to mention. So here is the charged particle Q. Q is the charged particle. Then it starts rotating in this way. Okay. Then this comes in. So therefore this is Q plus. So here we have in this direction. When Q is here, its velocity is like this. Velocity, let us say V, and then force which is applied is the downwards lines. This is called as what here? In the same manner, when the charged particle, this particular Q comes here means, okay, the velocity is represented like this. This is the velocity, and then force which is acting towards what here? And when a charged particle is here, okay, it starts moving in this direction, V, and the force which is acting towards the what here? Center, what is that? F. So then this starts what here? The rotating on its what here? In this way. Okay. So much. Now let us consider, let us I will say like this. So we have consider uniform magnetic field. That is being perpendicular to plane of paper. Q is a charge. Q plus is a charge. Is a charged particle. Introduced in it. Particle. V is considered as what here? V is velocity. So which is perpendicular to the what here? To the magnetic field. That is termed as an what here? B. It is perpendicular to the magnetic field. What I can able to say? B. Now, what is the force which is acting on this particular particle? What is the force which is acting on the what here? Particle. Let us say how much of the force which is acting on this particle. Okay. The force acting on this particle is given by what here? F is equal to Q into V into, what is that? B. We already know this. Okay, whenever it is kept in the what here? The magnetic field, the force acting on this charge, the force act on the charge, is F is equal to, Q is the thing but a charged particle, V is considered as what is the velocity, and B is the magnetic field. This can be written as, once again, I can able to write F is equal to Q into V into B into what is that? Sine theta. At what angle it is acting? It is a 90 degree, 180 degree, whatever it may be. If it is a perpendicular means, okay, the magnetic field is the perpendicular to the what here? This velocity. Then the theta is equal to, what happens here? Theta is equal to 90 degrees. Theta is equal to 90 degrees. Therefore, when sine 90 is equal to 1, so therefore this equation is becomes F is equal to Q into V. Okay. Sine 90 is equal to 1, so therefore we will get what here? F is equal to what here? QB into what is that? B. Now, let us consider this. Whenever it is starts rotating in this manner, in circular paths, there is a force which is acting towards the what here? The center, having a what here? Certain radius. It is having a radius here. So the R is considered as what here? The radius of that. Then the centrifugal force is acting towards the what here? The center. This is the center, means acting towards the what here? The charged particle is rotating like this. It is always acting towards the water, the center. Then we can call it the centrifugal force of this. Therefore, the centrifugal force, okay, the force acting towards the what here? The center. Okay. Then what is that force? We know that. Okay. Force acting towards the center is what here? Force acting towards the center. We can able to call what here? The centripetal force also. Therefore, F is equal to what? We well known formula is that F is equal to mv square divided by what is that? R. This is what we already know. Mass of the particle, the m is the mass of this particular particle. V is its velocity of the particle. R is considered as the radius. So then the force or the centripetal force is given by mv square divided by what is that? R. Let us substitute this formula to here. Okay, let us substitute this formula to here. So what we'll get? So this is considered as first equation. This is considered as second equation. From 1 and 2, let us say from 1 and 2. Therefore, mv square divided by r is equal to what here? Q into v into, what is that? So 1v is cancelled with the 1v. There's no doubt about it. So therefore, what is the r here? What is the radius of that? Okay, we can able to easily calculate. So therefore, we will get what here? R into Q into V is equal to what here? M V. 1 V is cancelled with the V. Just multiplies R into Q into what is that? V. So what is R here? So therefore R is the radius, that is equal to MV divided by what is that? Q. So this is the radius of what here? Charged particle. You just see here, radius is directly proportional to the mass and also what is that? Velocity. Directly proportional to the mass, as the mass goes on increases, the radius is also what happens here? Increases. Then another important concept is that as the velocity is very slowly moving, the velocity is very slow, then the radius is also what happens? Very less. Please compare these two things, radius and also the velocity. Velocity becomes what here? Very slow. Then it is here only. The radius is very less. Then it is increases. Velocity goes on increases. Then what happens? The radius is also becomes a what here? More. So this is unique here. So as velocity goes on increases, its radius is also what happens here? Increases. As a charged particle is moving here means its the velocity is very slower. Then it is here only. The radius is very small. Then if it increases means what happens? So the velocity increases, the radius is also what happens here? Goes on. So this is the radius of what here? The charged particle. Then we need to find out what here? The time period for this. So I want to find out the time period or a time. Okay. Let's understand what the time taken for the one what here? The rotation of this. Okay, time. What is the time here? Time is equal to distance traveled divided by so what you will say, the time. I want to know about the what here? The time of travel, the distance traveled divided by what I can say, the speed of this. Okay. How much of the speed you will get. So I can write this particular equation as the what here? The t is equal to the distance traveled is nothing but a what here? The entire circumference of this particular circle. Okay, one rotation. It starts from here and ends in here. So it is means that 2 pi r is. That is nothing but a what here? The circumference of the water. The circle. Okay, circumference. Therefore, it is nothing but a circumference. Divided by the speed is nothing but a what here? Velocity of it. So therefore, I will say like this, t is equal to, what is the circumference of the circle? You already know the c is equal to 2 pi r, I can able to say. Okay, it is nothing but a what here? 2 pi r. So therefore, 2 pi r divided by its velocity. That is nothing but a what here? V. Okay, that is the speed of it. You already know that the meaning of r. We have already identified that particular r. So therefore, t is equal to 2 pi divided by v into what is that? R. What is the r here? R is nothing but a what here? mv divided by what is that? q v. So v and v get what happens? Cancels. So therefore, what is the time taken for this? That is nothing but 2 pi m divided by what is that? Q. This is the time period of water, the charged particle. So charged particle when it starts rotating like this, for first rotation, t is nothing but a 2 pi m divided by what is that? Q into. Now we need to find out what here? The frequency. You know what is the meaning of the frequency? The frequency is nothing but a what here? Frequency. Frequency. F is equal to 1 over what is that? Time period. 1 by time per second. Okay. Now what is the time here? The time is this. So therefore the frequency is equal to 1 divided by what is the time period? 2 pi m divided by what is that? Q into B. So therefore the frequency is equal to QB divided by what I can even say 2 pi into what is that? This is the frequency of that what here? The charged. So that is the very easiest method we can able to find out about here the frequency of a water charge. Now we need to find out about here the angular frequency of this. Okay, I will take here itself. Okay, so that is an angular frequency. What is the angular frequency of that? How you will express the angular frequency? You already know that omega, it is always represented by the omega. So that angular frequency is given by omega is equal to 2 pi into what is that? Here it is a frequency. Okay, 2 pi into what is that? F. Okay, F. So therefore, what is F? You can keep like this. So omega is equal to 2 pi into what is that? QB divided by 2 pi into what is that? And 2 pi is difference. So what is the frequency here? Angular frequency omega is equal to QB divided by. So these are the 4 important things we need to study. When a charged particle is kept in a what here, the uniform magnetic field, its radius is this much, and the time is this one, the frequency is this one, and also the last one is what here, the angular frequency is this much. So this is the thing we need to study today. Okay. Thank you very much for watching the video. Thank you.